Hello everyone and welcome back to the channel. Today we are taking up question number 22 of exercise 7.3 integration. Grab your books and pen for the question and let's begin. Now in this question we only have denominator term. If we want to simplify this, we'll have to, we know when do we get cos of A into cos of B. We have cos A into cos B in the formula of cos A plus B, which is cos A cos B minus sin A sin B. And if you have minus here, you have a plus sign over here. And we have, if we take sin A plus B, we have sin A cos B plus cos A sin B. Again, if there is minus here, you have a minus sign here. So these are the two formulas which we can think of when you have a function like this. Okay. Now, we will be taking up the formula of sine. As we go on doing, we'll understand why we are taking sine. So let's multiply and divide with the constants. So suppose if we multiply and divide with sin A minus B, since it is the constant, the one with which we are dividing, we'll put it outside. We don't need that for the integration. So this term will continue up till the end, but over here we will write, or we will subtract and we will add x here. That was missing. If we do that, the angles will become similar to the denominator. So a little bit of adjustment here. Sine of, let's put x minus b first, and we don't want a minus x, we want x minus a. So minus sign common, x minus a. Cos x minus a into cos x minus b. Now we will apply the formula of sin A minus B. So the formula is sin A cos B minus cos A sin B. That is the reason we took the formula of sine, so that when we separate this out at a time, only one term will get cancelled. If we would have taken cos, we would have this in the numerator, and at one time both the cos term would get cancelled. Then we would be left with, suppose if we would have applied this, we would be left with 1 minus sin A, which is x minus A, and sin this upon. Now once again we have a problem here. Integration of 1 is possible because it was cos A cos B which got cancelled with the denominator. Integration of 1 is possible, but tan x minus A into tan x minus B. So again you would have to apply some formula in that. So we will take sine in here. We will multiply divide with sine. So when you have to multiply divide with sine, when both the functions are same, suppose you have both cos, both sine, then you multiply divide with sine. If you have different one, which we'll take up after this question, then we will multiply and divide with cos of the function. Now separate this out. So in the first term, cos x minus a will get cancelled. You will be left with sine by cos of the same angle, which is tan. In here, cos x minus b will get cancelled, and we have tan of x minus a. Integration of tan is log modulus sec x. So you can write that. So we have written integration of tan is log modulus x minus b and log modulus x minus a. You have to differentiate x minus b in the denominator, but the derivative is 1. Same for this one. Okay. Of course, yes, the integration constant c. Now, since the function is different, we will divide with cos a minus b and multiply with cos a minus b. Apply. Now we need to adjust this term. So we are going to add and subtract. So first I have subtracted, then I will add x. Adjust this a bit, like we will write it as cos x minus b minus x minus a. So what kind of angle you have in the denominator, according to that you have to substitute. This term will continue up till the end. It's constant. We just needed this to adjust the numerator. Now apply the formula cos a minus b, which is cos a cos b plus sin a sin b. So every time when you do this, only one term gets cancelled and the integration becomes possible. For this kind of questions, of course. So when you split this up, now you are left with cos by sine of the same angle, which is cot, and over here sin x minus b will get cancelled and we will be left with tan of x minus a. The first term was, one of these cos got cancelled, so cos by sine cot, and over here one sine got cancelled, sine by cos is tan. Now integrate that. Integration of cot is log modulus sine, and differentiating x minus b in the denominator, but that is again 1, and integration of tan is log modulus sec and plus c. So you just have to multiply, divide with cos of the angle over here. Now in case if over here we had a plus sign, then we don't want x minus b, we want x plus b. So we would have to multiply and divide with cos a plus b. So depending on the angle, again you have to see whether you should take cos a minus b or cos a plus b, and whether you should multiply, divide with sine or not. Same function, multiply, divide with sine. Different function, multiply, divide with cos. And angle also accordingly you should think. So it would go like this. If it was x plus b, then we would multiply, divide with a plus b angle, and when you adjust this, you subtract and add x, and x plus b minus x minus a. So now you see that the angles will be same and the rest remains similar. Okay. So this is how you can solve questions with cos sine as product in the denominator. So that completes with the exercise. The next video will be on exercise 7.10, which is based on properties of definite integration. So see you soon. Thank you.